Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at geometric sequences. So we already know what a sequence is. What makes it geometric is if there is a common ratio. A sequence is said to be geometric if when you take any term and divide by the previous term, you always get the same number, which I call R. So here R is the common ratio. So a geometric sequence is of this form. Start with any term, A. Next term is A times the common ratio. Next term is A times common ratio squared, and so on. This just says that each of these subsequent terms is being multiplied by R. So from that, we can easily get a formula for the nth term. We can see first term's AR to the power of 0, second term is AR to the power of 1, third term is AR to the power of 2, and so on. So the value of any of this term is just AR, and the power is 1 less than which term you're after. So this is an example of a geometric sequence, because if I were to take any term, like 2.5, and divide by the previous term, I always get the same amount. That's the same as 5 over 10. That's the same as 10 over 20. So here, all of these are equal to a half. The common ratio is a half. We are multiplying each subsequent term by the same number each time. It turns out to be a half. On the other hand, this sequence over here is not geometric. We need to times by 3 to go from the first term to the second term. Then we times by 2, times by 2, times by 3. We're not always multiplying by the same amount. 36 divided 12 is 3, but 12 divided 6 is 2. The ratio between successive terms is not common, therefore it's not geometric. Let's look at some questions now in which we find the value of a term. So this is our formula for calculating the nth term. If we want to find the 20th term of a sequence, we're calculating T20, so n is 20. We just take A, the first term, multiply by the common ratio. Now, if you don't know the common ratio in a GP, a geometric progression, then just take any term and divide by the previous term. Any term, divide by the previous term. So here it's actually negative 2. So R to the power of n minus 1 is 19. Now just make sure if you're substituting a negative into this formula, make sure you use brackets. So we can put that straight in our calculator as long as we have the brackets here, and we get 8,192. That will be the value of the 20th term. All right, let's try this one here. Calculate A and R if the fifth term of a GP is 20 and the ninth term is 1.25. So hopefully you're looking at this and saying, okay, I need to calculate two quantities at the same time, so we'll use simultaneous equations. So one equation will be the fifth term. The fifth term is always AR to the power of n minus 1, AR to the power of 4, and we're told that is equal to 20. Similarly, for the ninth term, AR to the n minus 1, n is 9 here, so n minus 1 is 8. That is equal to 1.25. Now here we want to eliminate either A or R, but we're not going to do it in the usual way. We're used to subtracting one equation from the other, but that won't get rid of A. What will get rid of A is if we divide. So just to keep things easy, I'm going to do higher power divide lower power. We're going to divide this by this. So A divided by A is just 1. R to the power of 8 divide R to the power of 4 is R to the power of 4. Now, 1.25 divided by 20 actually gives 0.0625 or 1 over 16. Now, just note, whenever you have an even power, there are two solutions. So the fourth root of 1 over 16 gives you a half, but there's also the possible solution R is minus a half. That occurs whenever the power is even. If the power is odd, there's only one solution. So let's go ahead and calculate what A would be. So if R is equal to a half, then A will just be 20 divided by a half to the power of 4. That'll give you 320. Now, if A is equal to negative a half, this will still be positive because negative to an even power is still positive. So there are two solutions. We have r is a half and a is 320, or r is negative a half and a is 320. All right, let's now look at one harder question. So which is the first term of this sequence here to exceed 1 million? So this sequence here is geometric because we have a common ratio. We are timesing by 5 each time. So we have that r is common, it is equal to 5. So we're going to use our formula Tn equals AR to the n minus 1. So again, there are 4 unknowns, just like there were when we dealt with arithmetic sequences. The 4 unknowns are T, A, R, and N. So you need to figure out which of these 4 you're being asked to find. I want to find n because I want to find the number of a term. I want to know, is it the 300th or the 23rd term or whatever? So I'm finding n, I'm going to substitute T, A, and R. So T is just the value of the term, so it's 1 million. A is the first term, so clearly equal to 7, and we already figured out that R is equal to 5. So this is the equation that we're solving. So dividing each side by 7, I get 142,857.14 blah blah blah. That is equal to 5 to the n minus 1. So n, the unknown, is part of the power. I'm going to use logs. N minus 1 will be equal to log of that number I just got, 142,857, and I'm going to divide that by log of 5. So we need our calculator for this, and we get n minus 1 is approximately 7.375. So adding 1 to both sides, n is approximately 8.375. So just as we did for arithmetic sequences, we need to round this up. We round it up to n equals 9. Even though this clearly is less than 5, we round it up to 9 because what we found is the 8th term will be less than 1 million. The 9th term will be a bit more than a million. So it is in fact the 9th term of this sequence that is the first to exceed a million. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.